These are the notes for section 10.3, matter and heat. So we're going to start with the question, why is it hard to eat an ice cream cone without making a mess when the temperature outside is 100 degrees Fahrenheit? Intuitively, I'll kind of know the answer to that, and you can see in the pictures, the ice cream will melt. So we're going to kind of take a look at that and see why that happens. So just a reminder, states of matter are the physical forms in which a substance can exist. That would be solid, liquids, and gases. They depend on the speed of the particles that make them up, on the attraction between the particles, and on the pressure around the particles. Remember back to chapter 2 when we talked about this, we said that solids are going to vibrate in place and they have a high attraction for each other. Liquids have overcome some of that attraction and they're going to slide past one another. And lastly, gases have overcome almost all of the attraction between particles and they are going to move independently. Another review, just a reminder, thermal energy is the total kinetic energy of all particles. Okay, so which has more thermal energy and why? If we're thinking about water, for example, a kilogram of ice, a kilogram of water, or a kilogram of steam. In this instance, a kilogram of steam would have more thermal energy because, like we've been saying, there are faster moving particles, higher temperature, and more energy. A change of state is the substance changing from one state of matter to another. Physical changes affect physical properties without changing the identity of the substance. So, for example, freezing, melting, boiling, condensing. And remember, change of state was our good example for physical changes because no matter if you freeze ice or you melt it or you evaporate it, it's still going to be water. Energy is added or removed as a change of state occurs. Remember, we said energy is added if you're going up the scale, so going from solid to liquid, liquid to gas, or it is removed if you're going in the other direction, so a gas to a liquid, liquid to a solid. Chemical changes happen when one or more substances are changed into entirely new substances with different properties. So, for example, food that you eat contains chemical energy. Your body must chemically change the food for you to use. And if you think back to chapter 9, this was actually a test question. We talked about your body changing that chemical energy, doing that energy conversion, and changing it into kinetic energy, or energy that you can use to move. A calorie is a unit of energy of a certain amount of food. 1 calorie, and notice that is calorie with a small c, is equal to 4,180 joules. So if you think about it, the average diet is about 2,000 calories per day. That's a lot of energy that we're using on a daily basis. A calorimeter is a device that measures heat transfer between food and water. And our last section is 10.4, heat technology. The sun gives off a huge amount of energy in the form of heat and light. And solar heating systems use this energy to heat buildings. Again, we mentioned this briefly in chapter 9 when we were talking about energy resources, things like solar panels. There are 2 types of solar heating systems, both active and passive. Passive systems have no moving parts, while active systems pump water across a solar collector, then pump the heated water throughout the building. If you think about our classroom at the beginning of the year, it acted like a passive heating system. We had the windows, the sun was shining in, and that caused the classroom to get very hot during the day. Thermal pollution is the excessive heating of a body of water. This happens frequently near power plants. Increased water temperatures and lakes and streams can adversely affect both plants and animal life in nearby ecosystems. The Davis-Besse nuclear power plant in our area is actually a big offender of this. The temperature near the power plant as opposed to the rest of the temperature in the lake can be a difference of as much as 10 to 15 degrees.